Morning. Welcome to my tutor. This is another edition of A levels. Today will be our first edition of Statistics 1. You'll be paper M21 P52. Let's go. A fair spinner with 5 sides numbered 1, 2, 3, 4, 5 is spun repeatedly. The score on each spin is the number on the side of each of the spinner lengths. Find the probably that the score of 3 is obtained for the first time on the 8th spin. So this random variable is geometric 1 over 5. There's a probability of success. So probability of x equals to 8 equals to 4 over 5 power of 7 times 1 over 5. Okay. Four over 5 power of 7 times 1 over 5. Okay. So the answer is 0.0419. Okay, find the probability that fewer than 6 spins are required to obtain a score of 3 for the first time. One of the reasons why this is called a geometric distribution is the sum represents like the sum of x smaller than 6, sum of a geometric series. So this will be 1 minus r is 4 over 5. Power 5 more minus p of n. Okay. So this is 5. So 1 minus 4 over 5 power of 5. 0.672. Okay. Starting from 2020, only this geometric progression is tested in this one. Okay, let's go to the next question. Georgie has a red scarf, a blue scarf, and a yellow scarf. Each day she wears exactly one of these scarves. The probabilities for the 3 colors 0.2, 0.45, 0.35 respectively. When she wears a red scarf, she always wears a red hat. When she wears a blue scarf, she wears a hat with probably 0.4. When she wears a yellow scarf, she wears a hat with probability 0.3. Find the probability that a random chosen day George wears a hat. Okay, you can put this in a tree diagram, or you can straight away do. The probability that he wears a hat is probability of, if she wears a red scarf, she always wear a hat. Red scarf and hat. That's probability of blue scarf and hat. That's probability of yellow scarf and hat. So she always wear a hat when she wears a red scarf. So this will be 0. Plus 0. Blue scarf 45 times 0.4 wearing a hat plus 0.35, which is yellow scarf, times 0.3 she wears a hat. 35 times 0.3 plus 0.45 times 0.4 plus 0.2. So this is 0.485. That is the solution. You can always draw a tree diagram if you want. Huh? Next question. Find the bride that on a randomly chosen day, Josh wears a yellow scarf, given that she does not wear a hat. Probability that she wears yellow, given that she does not wear a hat. Probability of yellow and no hat over probability of no hat. So probably yellow and no hat. Yellow is 0.45. No, yellow is 0.35. 35 and no hat is 0.7. Probably no hat would be 1 minus 0.485. 0.476. Okay, that's the solution. 0.476. Let's stop. Just take out the time spent by shoppers in a large shopping center has a normal distribution with mean 96 minutes and standard deviation 18 minutes. Find that the product that a shopper chosen at random spends between 85 and 100 minutes in the shopping center. So X is normal with mean 96 and variance 18 square. So this is probability that X is between. Okay, so standardizing, it is 85 minus 96, 18 Z, 100 minus 96 over 18. Of minus 11 divided by 18. Decimal value minus 0.611. Z 4 divided 18. 0.222. So you need to find this probability between 0 minus 0.611. Okay, so let's look at the probability table. 6. Oops, where is it? Okay. So 0.6111. 0.6111. 729726 7294. 7294. 1 minus 0.7294 plus do it a bit different. Put 0.222 first. 0.222 is 5879. 0.5879 minus 1 minus, now was what? 6.61117294. 7294. This will give you the solution. Okay. 1 minus 0.7294. 0.5879 minus the answer. So it's 0.3173. Okay. It should make the solution. I should give it in 3 significant figures. Okay. 80% of shoppers spend more than 10 minutes in the shopping center. Find the value of T. Okay, so it is this distribution here. 88% shopper more than 10 minutes. So, yeah. So here the area is 0.8. Yeah? So probability X larger than T equals 0.8. Huh? So you want to find the T value. Huh? Is moving it towards the other end. Huh? So you're taking, oops, sorry. You're taking positive value. Okay. So you just take 0.8 from your table and put a negative value. So area 0.8 corresponds with 0.842. 0.842. 0.842. T minus 96 over 18 equals to negative 0.842. Okay. So solving this would be 0.842 times 18. 96 minus the answer. So 80.8 minutes. So T 8. Okay. Next question. Question 4. Oh, sorry. This is 88%. My bad. So I got to look. I thought it was 80%. So it must be 0.88 lah. Yeah. 0.88. 88. 88. So it's 1.175. So it's 1.175. read the question properly then. $74.85. So the answer is 74.85. Or round it up to 74.9 minutes. 4.8 minutes. Okay. The random variable x takes the value 1, 2, 3, 4. The probability the x takes the value x is kx times 5 minus x, where k is a constant. Draw up the probability distribution table for x in terms of k. So probability of x equals to 1, kx 1 times 4. Okay. 2 times 3, 6k, probability x equals to 3. 2 times 3 also 6k. 1 times 4 is 4k. So the table is 2, 3, 4. 4k, 6k, 6k. That's it. That's the probability table. Show that variance of x equals to 1.05. So here you need to find what is k. So sum of x is equals to 1. So we add all, it will be 20k equals to 1. K equals to 1 over 20. So this is 4 over 20, 1 over 5, 3 over 10, 3 over 10, 1 over 5. So the expectation of x would be sum of x bx equals to x. So it's 1 over 5 plus 3 over 5 plus 9 over 10 plus. So this is 2, 6, 4, and 9, 21 over 10, 2.1. So variance of x. Let me find the expectation of x squared first. Expectation of x squared. Sum of x squared bx equals x squared. 1 squared times 1 squared times 1 over 5 is 1 over 5. 2 squared. 4 times 3. 12 over 10. 6 over 5. 3 squared, 9 times 3, 27 over 10. 4 squared, 16. So this is 2 plus 12, 14 plus 32, 46 plus 27, 73 over 10, 7.3. So variance of x squared minus of x squared. So this is equals to 7.3 minus 2.1 squared. There's an answer for you to follow. So the answer is different. 8 plus 6. Oh, I got this wrong. 8 plus 6 is 14 plus 2. 16. This is 2.5. The advantage of having a solution is you can always 2.4, 2.5. Okay, so this is 2.5 square. Let's see if I can get the answer now. Should be correct already. 1.05. Okay. Driver records distance traveled in each of 150 journeys. These distances correct to the nearest kilometer are summarized in the following table. Draw a cumulative frequency graph to illustrate the data. Okay. Smaller than 4 is 12. Smaller than 10 is 28. Smaller than 20, 60. Smaller than 30. 126, smaller than 40, 146, 60 is 150. Okay. So it's up to 150 to 60 only. 0, 2, 4. Not very 4, 6, 8, 10. 2, 4, 6, 8, 10. 4, 6, 8. Hit this. 2, 4, 6, 8. 2, 6, 2, 4, 6, 8. 10, 20, 30, 40, 60. Okay. So it's 150. So this is 1, 2, 3, 4, 5, 6, 7. So it's 20, 40, 60, 80, 100, 120, 140. So less than 4 is 12. Yeah. Less than 10 is 28. Yeah. 60, less than 20, 60. Less than 30, 126. Okay. 146, less than 40, 146. Yeah. 60 is 150. Okay. So it's not going to be a very good graph. I just used red color pen. Try drawing the line. Huh? Okay. It's the best. Okay. For 30% of these journeys, the distance travel is d kilometer. Use your graph to estimate the value of the 30%. 30% of 150 is 45. So 45, huh? See here. Oh, D or more. So it must be the top. Wrong already. It must be the top 30%. So it would be 105. Yeah. So it's about 25 according to the graph. So it might be different. So if you draw your graph, it will be somewhere between 25 and 27. So my graph is 25. Okay. Calculate and set the mean distance traveled for the 150 journeys. This is very tedious. Two times 12. 7.5 times 16. 15.5 times 32. Very tedious. 25.5 times 66. Five point five times 20. The last one is 50.5 times 4. So finding mean is very tedious. If you are finding standard deviation is even more tedious. So try and make sure you don't make a mistake. Keying in the values in your calculator. 5.5 times 20. 2. See? 50.5 times 4. 3235 divide 150. So the answer is 21.6. Okay, tedious, but not difficult. Next question. Question on permutations and combination. Find the total number of different arrangements of the 11 letters in the word caterpillar. So non-distinguished permutation. So there are 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 11 alphabets. So it will be 11 factorial over the number of repeats. A, T, E, P, R. There are 2 R, 2 A's, 2 factorial times 2 factorial times 2L. So it will be 11 factorial divided by 8. Straight up be 4989600. Let me check again. It's all the repeat. Not correct. Okay, it's correct. 2A, 2R, 2L. 4989600. Find the total number of different arrangements of the 11 letters in the word caterpillar. in which there is an R at the beginning and an R at the end. So there's R here, R here. This is 9 alphabet here, so 9 factorial over. There's 2 A's, 2 L. Equals to. Question here is not too difficult. 90720. Surprised. Find the total number of different selections of 6 letters from 11 letters of the word caterpillar that contains both R's and at least one A and at least one L. So they want 6. So you're supposed to choose 6 letters. 6 letters, huh? You must have R, 1A, at least 1A, and at least 1L. Okay, can we have 2A, 2L, doesn't matter. So there are 7 alphabet left. You need to choose 2. So it's 7, C2. Okay. Not too difficult, this question. Okay, next. There are 400 students at a school in a certain country. Each student was asked whether they preferred swimming, cycling, or running, and the results are given in the following table. The student is chosen at random. Find the price that the student prefers swimming. Okay, let's look at how many students swim. This is 135. This is 107. This is 158. So if you add horizontally, 154, 220. So this should be 180. Yeah, 180. Okay. So probability swimming is 135 over 400. 35 over 400. 7 over 80. Okay. Determine whether the events the student is male and the student prefers swimming are independent, justifying your answer. Probability the student is male is 120 over 400, which is 3 over 10. Okay. Probability of male and swimming. Male and swimming is 31. Probability of male times probability of swimming equals to 3 over 10 times 27 over 80. Times 0.3. 81 over 100. 800. Is not equal to 4. Not independent. On average, all the schools in this country, 30% of the students do not like any sports. 10 of the students from this country are chosen at random. Students do not like any sports. Find a point that at least 3 of these students do not like any sports. So this is a binomial distribution. Do not like any sport. NP. n is 10, p 0.3. Probability of x at least 3 equals to 1 minus probability of x equals 0. Probability of x equals to 1 minus probability of x equals to 2. Then C0. Zero 0.3 to the power 0, 0.7 to the power minus 10 C1, 0.3 times 0.7 to the power 9 minus 10 C2, 3 square times 0.7. Question is not difficult, but it is very tedious. So it's 0.7 power 10 plus 10 times 0.3 times 0.7 power 9 plus 10 C2 is 45 times 0.3 square times 0.7 power 8. 1 minus answer. So it's 0.617. That's the solution. Okay. Next. "90 students from this country are now chosen at random. Use an approximate to find the probably that fewer than 32 of them do not like any sports." So this is x is binomial 90, 0.3. So approximate to normal, and p, which is the mean, which is 27. So 27 times 0.7. 18.9 is the variance. So probability of fewer. So you standardize together with continuity correction. So it's less than 32, you take 31.5 minus 27 over 1.5 minus 37 divided by square root of 18.9. So you get 1.035. 1.035. So this is quite direct. So you look at the table 1.035. 1.03847. 0.8497. That is the answer. Okay. So rounding it up, it is 0.850 to 3 significant figures. That's it. This is the first statistic paper. If you like it, put a comment, subscribe to this channel, put your email. I will email this paper to you. Bye for now.